The next video in the Science of Matter unit is on the properties and change matter. We have two learning targets for this video, first of which we want to be able to differentiate between and identify physical and chemical changes. A physical property is a property that can be observed without changing the identity of the substance. So for example, color would be a physical property. We can look at an object or substance and we can observe its color. We don't have to change the identity of what that substance is to make that observation. Another example would be hardness or shape, boiling point, or solubility. Also the physical state, is it a solid, liquid, or gas? All of these would be examples of physical properties. A physical change is a change in which matter does not involve a change in substance. In other words, we change it, but it's still the same stuff. Examples might include a phase change. So, for example, the freezing of liquid water to form ice, or a change of shape, or the change in temperature. You put your Gatorade in the refrigerator to cool it down. Still the same stuff, just changed temperature. So that's a physical change. A chemical property is a property that's observed only when there is a change in composition of a substance. So for example, we can say that iron rusts at room temperature. When iron's rusting, it's no longer iron, it actually turns to iron oxide. That's an observation that's only made when it does change substance. We could say helium is inert. Now inert means it doesn't react. So even though helium is still helium, the point here is we're trying to get it to change to react to something and it won't. So that would be a chemical property. A chemical change, or otherwise known as a chemical reaction, is a change of one or more substances into other substances. In other words, this is the process by which we can observe chemical properties. Examples would include burning of wood, rotting roadkill, the ripening of bananas. Here's a practice problem, and you simply want to identify each as a chemical or physical property or change. For the first one, the density of aluminum is 2.7 grams per centimeter cubed. Ask yourself, is that an observation that we can take without changing the identity of the aluminum? The answer is yes, we can. So that's a physical property. The temperature of the oven is 375 degrees Fahrenheit. Can we measure the temperature inside of the oven without changing the identity of the air inside it? The answer is yes, of course we can. So that's also a physical property. Hydrogen is flammable. Well, if something's flammable, that means it burns. And if something's burning, it's certainly changing the identity. So this is a chemical property of hydrogen. The table is 2.35 meters long. That's a physical property. We can take that measurement without changing the identity of the table. Water boils at 100 degrees Celsius. This is often a confusing one for students. We think of water boiling, we picture the bubbles that get formed, and often students think of a chemical reaction. The thing about any phase change is it's still the same substance. When water boils, it's still H2O. It's just going from liquid water to water vapor, so it's still water, that meaning it's a physical property. Milk sours in the refrigerator. This is a chemical property or a chemical change. When you drink the milk before it's soured, it's milk. When you drink it after it's soured, that's not milk anymore, meaning it's changed its identity, so a chemical change. So we've differentiated between physical and chemical changes. Now we want to learn a little bit about density here. Density can be defined as the mass per unit volume of a substance. We calculate density by taking an object's mass divided by its volume. Here is an equation that can help you. You've used these in physical science, and we'll look at how we get equations from this. To get this density equation here, we just cover up the D, and we see that M is on top of V, so that would mean we divide. Mass divided by volume equals density. The units on a density are most commonly in grams per milliliter or grams per centimeter cubed. Now a note about these two units, they're actually exactly the same. A milliliter is the exact same thing as a centimeter cubed. The reason why we have different units is oftentimes you'll see the gram per milliliter for liquids and grams per centimeter cubed for solids, but they're actually the exact same unit. There's nothing different about them. To put this in perspective, the density of liquid water at 4 degrees Celsius is 1.000 grams per milliliter, or you can just say 1 gram per milliliter. The density of liquid water at any temperature is close enough to 1 that we just say the density of water is 1 gram per milliliter. Density is an intensive property, meaning it does not depend on the amount of matter present. When we say the density of water is 1 gram per milliliter, we don't have to say how much water is present. Whether we have a cup full, a bathtub full, or an entire ocean full of water, the density of that water is the same, 1 gram per milliliter, regardless of how much we have. Let's look at some calculations now. First question, determine the density of a wood block with the dimensions of 3.4 centimeters by 8.6 centimeters by 2.1 centimeters and a mass of 44.80 grams. So from our equation here, if we cover up the D, meaning density, we can see density equals mass divided by volume. So there's our equation. And just plugging in our values, we're told the mass is 44.80 grams. The volume, we need to take length times width times height. So we 3.4 centimeters times 8.6 centimeters times 2.1 centimeters. And that's going to give you 0.73 grams per centimeter cubed. Notice the units here. On top we have grams in the numerator. In the denominator, centimeters times centimeters times centimeters, that's centimeters cubed. So that's how we get the unit there. Next question. What is the mass of a copper cylinder? And we're told the density of copper is 8.90 grams per centimeter cubed. That has a volume of 25.5 centimeters cubed. So here we're asked to find mass. So in order to use this equation here, we cover up mass, and we see density is next to volume. That means we multiply. So mass equals density times volume. We can substitute in our values here. We have 8.9 grams per centimeter cubed, that's just here from the text, times 25.5 centimeters cubed. Notice your units here, centimeters cubed cancel. The centimeters cubed in the densities in the denominator, the centimeter cubed in the volumes in the numerator, so they cancel. That leaves us with grams, and if you think about the problem, we're trying to find mass, so we should be left with a mass unit. And this will give you 227 grams for your mass. What volume of liquid mercury, and we're given the density here, 13.5 grams per milliliter, is required to fill a thermometer if it contains 0.125 grams of mercury? So now we're asked to find volume. So in our equation here, if we cover up the V, we have M over D. That gives us mass divided by density. So volume equals mass over density. Plugging in our values, we have 0.125 grams divided by 13.5 grams per milliliter. Again, check out your units here. Grams cancel. One of them's in the numerator, the other one's in the denominator. We're left with milliliters, which we should. That's a unit of volume. And that gives us 0.00926 milliliters. Next question. To determine the density of an unknown, irregularly shaped object, you find its mass and use water displacement to determine its volume. The mass of the object is 43.05 grams. You place the object in a graduated cylinder containing 23.2 milliliters of water, and the water level rises to 28.6 milliliters. Determine the density of the object. So here we're asked to find density, so that's just our mass divided by volume, as we've seen before. Notice in this situation, we're told that we're using water displacement, and we're given a volume of water in a graduated cylinder before we add the object and after. So we'll have to use those two values to determine the volume of our irregularly shaped object here. So plugging in our values, we have our mass of 43.05 grams, and the volume would be the difference between the two volumes that we read in the cylinder. So 28.6 milliliters minus 23.2 milliliters. If you plug all that in, 28.6 minus 23.2, that would be 5.4 milliliters, and then do the division. That will give you 8.0 grams per milliliter for the density. So we've looked at performing some density calculations. Hopefully, after seeing these examples, you can do some on your own.